Okay, in this video, we are going to talk about what are called inverse trigonometric functions. So far we've dealt with sine, cosine, and tangent and their reciprocals. But now we want to look at how do we solve a problem that is something like sine of x equals square root of 2 over 2. So usually, or thus far, all we've dealt with is things like what is the sine of pi over 6 or something like that. But now we want to deal with what if we know the value of the sine but not the angle. So just like when you did inverse functions and when you did logarithms, what we can do is we can define an inverse function for trig. And so we define these as sine inverse of x. We also write this as the arc sine of x. And they both mean the same thing. They're the inverse function of sine of x. So what does that mean? That means that sine inverse of sine of x is equal to x. Now, I can't stress this nearly enough. Sine inverse of x does not equal 1 over sine x. These are not the same thing. This is the reciprocal. This is the inverse function. They are two very different things that people mix up a lot. So don't make that mistake. So the sine inverse acts on sine of x. It is a function. So what we can say is if we have sine of x equal the square root of 2 over 2, we can take sine inverse of both sides. And so we get that x is the inverse sine of square root of 2 over 2. Just like when you had exponentials, you would say something like x equals log of 2. Well, it's the same thing. You can plug this into your calculator, or if you just know it, you can say that x equals 5 over 4. Okay, so let's talk about how you should read this in order to make it make a little more sense to you. So whenever you see sine inverse of x, the way you should see this in your mind, or read this the first time you see it, is to say this value is equal to the angle whose sine is x. Okay, so when you see this, say this value, whatever it may equal, it's the value whose sine is x. So in this case, the value whose sine is square root of 2 over 2 is pi over 4. So when you take the sine of a number, or you're taking the sine of an angle to get a number, the sine inverse gives you an angle. So whenever you see this, you're looking for an angle. Whenever you see sine of x, you're looking for a number. Okay, so we can do the same thing for cosine and tangent. We can define inverse functions for those just as well. We can say the inverse of cosine is the inverse cosine, which equals also, we call it the arc cosine. It's just a different name for the same thing. And for tangent, same thing. Now once again, I'm going to stress this because this is such a huge mistake that people make. This object is not that. And the reason people make this huge mistake is because for some reason we like to say cosine of x squared, and we write that as cosine squared of x. However, even though we say this for all exponents, we're saying cosine to the n is cosine n of x. We don't do this for -1. So cosine of x to the minus 1 is not cosine inverse of x. So this may be one of the reasons some teachers prefer the arc tangent or arc cosine, so there's no confusion between these two things. Okay, well, let's do another example. So let's say that we had cosine of x was equal to, let's say, 1/2. Well, we want to solve for x. So how do we do that? Well, we just simply take inverse cosine of both sides. Okay, well, we know this side is x, and the other side is going to be just cosine inverse of 1/2. So now we have to ask ourselves, what is the angle whose cosine is 1/2? The angle whose cosine is 1/2 is x, and x is what we want. So if we remember back to our unit circle, we know that the angle whose cosine is 1/2 is pi/3. Because with our unit circle, that angle looks like that. So the cosine is 1/2. Okay, so now that we've seen this, let's look at a little bit more of the technical details of this, because we have to be really careful when looking at these inverses. Because I could say that sine inverse the square root of 2/2 is pi/4, but we also know that the angle whose inverse, or the angle whose sine is square root of 2/2 could just as well be pi/4 plus 2 pi, because they're in the same place. We just run around one time. So is there more than one answer? Well, the answer comes from the properties of inverse functions. So if we look at the graph of sine of x, we notice that this fails the horizontal line test miserably. So if we were to ask what the inverse function is, we couldn't do it because it's not a one-to-one function. However, what we can do is we can break up the graph as long as it covers all possible values. So what we say is we're going to restrict ourselves to this domain, because if we look at just that, we look at just this restricted domain from minus pi/2 to pi/2, then we see that we actually get a one-to-one function. So here's our restricted values of sine of x, such that sine of x is 1-to-1. Okay, so if this is our value of sine of x, well, sine of x is now in the domain, negative pi/2 to pi/2. So if we're asking for sine inverse of x, its range has to be between these values because the inverse function has the range of the domain. So when you ask this, the answer you get is going to be between pi/2 and negative pi/2. So if you were to type this into your calculator, sine inverse of 0.5, you would get a value between these two numbers. Now, when you go to plug in your values of x, x better be between -1 and 1, because there is no angle whose sine is 4, for instance. It has to be between -1 and 1. Okay, so let's look at cosine. Cosine looks like that. Okay, so again, we want to cut this off such that it is a one-to-one function. So the way we do that, you start here, the origin, and go to here. Because this takes on every value cosine can take on, and it's 1-to-1. So we're going to look at the values from 0 to pi. So if we look at this, we see that our values for the inverse function, if we ask the angle whose cosine is 0.1, we're restricted to getting answers between here and here. So we say that the cosine inverse of x is restricted between pi and 0. But just like with sine, x still better be between -1 and 1. So if you were to plug in inverse cosine of a half into your calculator, you would get something in this interval. Well, let's look at tangent, because tangent actually makes a little bit more sense. So tangent, which looks like this, a lot of asymptotes, and just repeats this cycle forever. Well, we never want to cross an asymptote anyway, so it makes sense to restrict our domain of tangent from here to here, which is minus pi over 2 to pi over 2. So we say that we're only going to look at this region, so when we look at its inverse function, and this one's going to be actually strict equalities, because if we go to this point, then you're going to have an asymptote. So we're going to have between negative pi over 2 and pi over 2. So let's look again at why this should be a strict inequality rather than greater than or equal to or less than or equal to. So if we look at an inverse function and we want to graph it, we really just need to reflect the graph through that line. So let's do that first with tangent. So for tangent, this is going to look like, well, we flip our x and y, so this is now going to be negative pi over 2, pi over 2, and there's going to be asymptotes here, because we've now turned the graph on its side. And so we know it's still going to cross at the origin, but now instead of going like this, it's going to look something like that. And this is f of x equals tangent inverse of x. So if you were to say, what angle has the tangent of 3? You would just look. You would plug in 3, go up to the value, and find it. So, as we look at this, we can see that no angle will actually ever have a tangent. You can't plug in any values to get a tangent of pi over 2, basically. So, as tangent inverse, as x goes to infinity, as your angles, or as your tangent gets very large, the inverse tangent goes to pi over 2, basically. So as x gets big, the inverse tangent goes to pi over 2. Okay? So, and that corresponds to as your triangle gets smaller and smaller, your tangent goes to infinity. So as your tangent goes to infinity, inverse tangent goes to pi over 2. That's what I'm trying to say. So that is the gist of inverse trig functions. You use them pretty much the same as you would a log for an exponential, except you're using trig functions. So keep your logarithm basic rules in mind. The specific log rules don't apply, but the idea of inverse functions do. So just remember your inverse functions and remember what these graphs look like, because they're fairly important.